Welcome back, and this week we're going to start off with kind of a review problem. And so I just want you to compute the integral from 1 to 2 of 2x e to the power of x squared dx. Okay, so pause the video, take a shot at that. Alright, well, hopefully you had time to pause the video and do some work, and you might have seen this and said, oh, well, it might be a good idea to use a u substitution. This is from Calc 1 of x squared, and then du is going to be 2x dx, and then when we did and then when you use a substitution, we got, well, let's see, that's going to be e to the u, and then the 2x dx is precisely du. And then since we have a definite integral, remember we have to change the bounds, right? So 2, those are bounds for x, so to get the bounds for u, I need to square those, so 4 and 1. And so then when we evaluate this whole thing, we just get e to the fourth minus e. Okay? And so this process we learned back in Calc 1, and this is really the basis of what we're going to be doing today. But a couple questions before we get there is, notice that when we did the u substitution, we had to change the differential, right? We had to change the du, okay? And so there was a precise method in how we do that, and similar for the bounds, right? So we had to change the 2 and 1 to 1 and 4 because we were changing from x to u, so we had to change that. But then now the question that we have in our studies currently is we've been studying double integrals, well, double and iterated integrals, right? And so the real question becomes, how do we change, or how do we adapt this process to be useful for us when we're doing double and iterated integrals? Okay, so that's kind of the premise for today, and in the next video we'll get started on this idea.